now have our first panel discussion, and the chair is Alastair Basden. He's from Durham, among other things, manages the Dirac system at Durham. He's co-chair of the Dirac Technical Directorate and technical lead for the Dirac Data Curation Service, and many other things. So, over to you, Alastair.
Thanks, Mark. Fire alarms, you were going to mention. Fire alarms. We don't know if there are any fire alarms, so if there are, get out, I guess. Okay, well, welcome to our next session. We're going to talk a little bit now about technology, innovation, and sustainability. And we'll be looking for questions from you lot, of course, for the panel. There's a panel member missing. Oh, Sadaf's gone, hasn't she? But to kick it off, I've got a question for the panel, first of all. So this is on the sustainability front. We've talked a bit in the few talks that we've had today so far about sustainability. One thing that we haven't really talked about is embodied carbon. So the carbon that is produced during the manufacture of our kit. I guess that's the scope 3. Is it scope 3? Where do you see that fitting in, and how important is that to take into account?
Okay, I guess I should.
Yeah,
it's working. I think it's always a journey, and there's every little help in some sense, or every part helps. Scope 3 might be the last part. It's always important, and I think it's possibly the topic of recycling. Right? If we can recycle the material that we use, that's going to possibly have the biggest impact, because a lot of problem is things like batteries. Once their lifetime is over, you can't do anything with it. So you really lose a lot of material. So if one way to improve the CO2 footprint of production would be if we can recycle equipment and also repair the life cycle of equipment or any everyday item. If we think of all the components, if we could repair RAM in servers, the box is still fine, right? We would possibly don't need to change the box. So it's kind of this repairable component would be a big important step that nobody wants to consider. And then the recycling part, I think that's probably possibly the easiest thing to do, but not that something that people think about.
One thing I haven't seen analysis on is the kind of equation of when do you get rid of something versus keeping it for longer, in terms of, the energy inefficiency as things get older. When is the optimum time point to swap it out? Because of course that embedded carbon cost should come into that equation. But I haven't seen anyone model that. I don't know if there are papers on that. Have you seen any?
Well, we did. I did some calculations on that based on our kit in Durham. Mm-hmm. So Durham, for those who don't know, northeast of England, and a lot of our power comes from wind turbines and North Sea and so on. So we have quite a green energy mix most of the time there. And we worked out, based on embodied carbon measurements that were provided by Dell. It was approximate, because you don't exactly know what CPU model you get and so on. But based on that, and on our average over the year, average carbon intensity of the national grid where we are, we worked out that we would need to run our servers for about 18 years so that the embodied carbon matched the electricity carbon. Now, if you took, I then redid that for the country as a whole, and there it came to about 3.5 years, and redid that for the worst area of the country. I can't remember where that was now, and that was more like 2.5 years. But so it depends a bit where you are, how long you need to run for.
And then another trend I think that's going to emerge, maybe not for small scale use, but for large scale use, of these rack scale architectures that vendors are coming out of, where you have a very large non-standard rack with all the cooling and power infrastructure built into the rack, with buzz bars and kind of custom water cooling and blades that you could probably take in and take out. So that kind of recycling where the chassis has a longer lifespan. So I haven't seen the pricing, but I can imagine these things are going to be horrendously expensive, and to make the economics work you probably have to keep them. It's great for vendors because they lock you in, but then you're locked into that particular chassis that you spent a fortune on, and you're just changing the blades. Yeah, so in a way, there's recyclability in there by accident because it's useful for vendor locking.
Good. Any other thoughts from the panel on this topic? If not, I'll throw it out to the audience. Any questions for our panel? Alastair.
I was thinking while you're talking, one of the ways that lots of countries are trying to reduce or improve sustainability is by outsourcing their computing, whether it's via cloud. There's lots of data centres in Ireland, or encouraging people to use facilities like Lumi and some of the Euro HPC stuff. So that then tends to reflect well on the UK, and it saves us a bit of money. So what's your view on the relative importance of national sovereignty and having a lead in these sorts of things versus the sustainability argument?
That's a different one. I think sustainability has nothing to do with that discussion, really, in my opinion. No.
Whatever you said made me think.
It's a good way to change the subject. Because someone's paying the carbon. I don't think the planet really cares whether the carbon emerged in England or whether the carbon emerged in somewhere else. But the sovereignty thing is a different question, right? And so there are several angles here, isn't there? So talking to my DC colleagues about why they think it's important to invest in AI data centres in the UK, it's the GVA that goes with it, right? So there are lots of studies, economic studies, that would say that a 100 megawatt data centre will create £400 million a year GVA. That's in England, if it's in England, or if it's in Scandinavia, if it's in Lumi. And I think the government want that money here, one. Two, if you're developing AI models on sovereign data, you might want the law that governs that model to be UK law and not Lumi law. And so there are governance, legal issues why you might want those models to be under your national jurisdiction, and obviously economic benefits. Why would you give another country all that benefit and not the UK? So I think there are two pretty good reasons why the government want it here, I guess.
Anyone else from the panel want to chip in? If not, any other questions?
No. I mean, there is a very challenging question for today's time. But if you historically see, I mean, computing is becoming commodity. Okay, so this when we are talking about this outsourcing and all, I mean, whatever has happened for jobs, regular jobs, wherever in the world the cheapest, the jobs go there, or some of the tasks. So I don't think we are seeing anything different in computing. So this flow will continue. Of course, there are all these issues, as you said, legal issues. It's the same problem, but it's coming in a little bit different, complex manner. And I don't think there is any very quick solution to this. We just have to live with it. Whatever constraints, different governments, they have some agreement, and we'll see. Especially the AI models, I mean, as you said, Paul, I mean, which country's data you take and who will share that model. I mean, that model of global use, then people will say, yeah, let's go for it.
And whose law is governing that model's use, that's the thing. Right?
Yeah.
So you want to regulate something, you'd like that regulation to probably be your regulation, not somebody else's.
Yeah.
There was also the comment about the scaling up to have massive data centers, and then I think some aspect would be moving the compute where the energy production is, so that you don't have to transport it.
Yeah.
So I think that's one aspect to consider. I mean, a nuclear power station can be put more or less everywhere. But if we want the renewable energy sources, then the north or windy places would be a good place, or desert places. The aspect I didn't talk about is the aspect of heat, how to recycle heat. That's so one hope I have is to have a data center and a swimming pool at Keele, because we don't have a swimming pool on campus yet, so that's my next plan. And then but the aspect of heat is quite important. You mentioned water cooling, right? And you want a closed system, very safe system. I was surprised the racks were not elevated to have allow flooding on the ground. But I guess there's not so much water involved in water cooling.
The flooding, and we've had some floods, it's too late because normally the server that floods is the one at the top of the rack. And that water goes through every server all the way down to the bottom. So you don't have to worry about water coming up from the bottom, you worry about water flowing down through all the servers. Yeah, so when you have a leak, that's when it bothers you, when it was in...
Is that a when and not an if?
It's a when, yeah. It happens in the top of the rack normally. It normally happens at 4 in the morning when there's no engineers in the facility either. Yeah. So it floods for a good, I've never pressed a server before and water comes out. Like a sponge. It's not water, of course, it's glycol, so it's even worse. Wet servers.
Okay, any other questions? Yeah.
So in the chat about sustainability... So in the chat about sustainability, it talks about building bigger data centres and training these models and the want of the UK government to have control over this. Do we have the people in the country to actually train these models to use these data centres to worry about sustainability anyway? That's because I'm not sure we have. It seems like a lot of the people have moved to the big tech companies anyway.
So we've been advertising for roles recently for the air service, and actually we found it pretty oversubscribed. So the AI market is much more buoyant for people than the HPC market. So, AI positions were oversubscribed 30 to 1. My HPC admin jobs, I'm lucky to get one applicant. But it's the experience level. The experience level seems quite good. So AI is generating a lot more candidates than HPC jobs.
So have you tried advertising AI HPC sysadmin?
Yeah, that's what we're doing now.
A link to
real candidates?
Apparently so. The Sadaf found this as well, where she was hiring. She had a good lot of applicants for Isambard.
Well, related to your point, if you have the infrastructure, you can attract also the community. And then you build the community, you build the knowledge. So it could be a circular argument. Yeah. I think your point about innovation, how to drive innovation, I think you mentioned co-design, but also how to invest in people. And for me, the students' population could play a major role. Like Dirac does some project or placements during PhD programs. If we had a system of summer projects to expose all the finishing final year students, then these students go everywhere after that. They go into industry. And for me, that I see this is the way to start the process of building that community, training the next generation.
Yeah, but it's a really good point that you made. Obviously, that is getting that sausage machine working and putting young students in one end. It's we need to do more there because the demand is huge. But I think there's an equally large interest, I think, from the student base.
Okay, I'm just going to just check first of all, Brian, are there any questions online?
Not yet.
No. Okay, brilliant. There's a mic behind you. There you go.
So I guess one way to conserve energy is also to do less training all the time. So the work of foundation models, for example, is a big community. So how could we maybe improve the use of foundation models where somebody has pre-built a model and not everybody has to rerun training every time? And that doesn't happen in HPC, but it happens in AI. So how do we leverage on foundation models better to conserve and make systems more sustainable? Thanks.
Well, that's an interesting one. Again, the talks earlier were discussing how AI techniques are creeping into the simulation space. And of course, that is saving huge energy because it's using a lot less compute. So again, by having foundation models for science and using AI augmented simulations will save 100x power, 1000x power. Of course, you had to create that model in the first place, so there's a just once, and then by having communities of practice and signposting these things, I think there's huge energy savings that can come there.
I think Omar, what you are saying is very idealistic. If you look at the academia, look at the industry, everybody is trying to get a competitive advantage over others. Especially when the field is moving so fast. If, let's say, I'm just putting you on the spot, you get a $20 million funding. You go ahead. You go ahead with your new foundational model and you keep on doing. You don't care for others, right? So that is reality. Okay. So unless government mandates saying, okay, I'm giving you 20 million, but make sure that you share this model with all these UK people, then you will have to follow. I think it has to come from the top. I think these are a lot of societal issues. The same thing with me. I'm not. If somebody gives me the same amount of money,
you know what will control this. I find with my users and people in general, one of the best things at controlling human behaviour is money, and it's going to be expensive to run and do that yourself again, and that will just prohibit people, so they will have no choice because they won't have the money.
Yeah.
And so economics will drive efficient behaviour because there aren't that many companies that can afford to do that. So I think economics is on your side.
Okay, I think there was a question somewhere at the back. Chris, wait for the mic. It's coming.
So both Raphael and Paul talked about heat reuse. Do you see a trend towards moving compute to universities where you can reuse the heat to heat university buildings, the student accommodation, showers, etc., or to super efficient big central data centres? And if you do federate and distribute the compute, what algorithms need to check? What happens to the algorithms? Do they need to change to make use of that distributed compute?
So I think heat reuse is actually, in practice, quite a tricky thing. So either it's a small data centre, when you can get rid of that half a megawatt or a megawatt with some local heat circuit, if you're prepared to put in the investment because the payback is long term. When you get large, there are some projects I'm working on at the moment, looking at a 100 megawatt data centre. That's really difficult to get rid of 100 megawatts of heat. When you actually think where you can put that, it's really hard. And so I think heat reuse is a little bit of a red herring, I think, a lot of the time. I think it's difficult. Unless you can put an adjacent industry next to the data centre. So I think, again, the government are thinking of energy-intensive segments where you might co-locate beer, apparently.
Greenhouses, beer. Yeah.
So beer, HBC beer.
Whiskey as well.
Yeah. So there might be a renaissance in the UK in the beverage industry with all the data centres that the government are trying to create. But that kind of thing. I think industry, farming, maybe greenhouses, but it's otherwise domestic reuse is really challenging once you get over that kind of size.
It has to be integrated, right? So even I talked about a solar farm at Keele. Solar farm was not built for computing, right? It's built with estate, local authorities. So it really needs coordinated planning. It's easier to build
heat circuit where you pass energy through a number of players, and then a data center can be part of the solution instead of part of the problem, but only if it's in some municipal kind of circuit and there's a flow of power through different usage. But that takes a lot of planning, and then your data center goes offline and all your students freeze.
They do ride bicycle to generate an electric.
You put the system into maintenance mode for the afternoon, and no one's got any hot water in your municipal area. But so it's tricky.
I think the other problem is that a lot of university estate is quite old, isn't it? And so it takes it could be a 10, 15, 20-year plan.
Yeah, well, and the funding is a problem. Because if I'm going to commit to a municipal heating circuit, my heat source needs to be there for the next 30 years.
Yeah.
The UK government doesn't fund anything past the end of next week. So how are we going to plan for 30 years when we don't know what we're doing next year in terms of heat? So it's really, you can't rely on that heat switch being there. There's no program, there's no commitment. That's difficult.
Okay, any other questions? If not, one from me, another one from me. So we've talked a bit about kind of optimising. How do you get the balance between effort that you put into optimising the hardware and effort that you put into optimising the software codes? Given fixed levels of funding, etc.
What funding? The software codes?
Well, if there was,
in the UK?
Excalibur, for example.
Okay, Excalibur, sorry. Yeah, so that we don't do it, really. Yeah, we don't really.
But how should we? I think that's the question. How should we? What
100x
balance? 100x more on software
yeah.
and nothing on compute.
We spend all our money on end of tax year capital assets because we can do that without a plan. So you can do end of tax year capital procurements and you don't need a strategy or a plan. To do a software program, one might need a plan, maybe. That stretches out for 5, 10, 15 years. Have we got such a plan? Have I missed that too? I'm looking at you. Do we have a plan?
It's unfunded.
No.
We have a plan.
We have a plan for a plan.
No funds.
Yeah. So the software tech strategy takes time. We don't do that in the UK.
How about any comments from DK, given that you've spent a lot of time
US is different. You have
optimising and so on. What should we be doing here that we're not, I guess?
Yeah, I mean, in US, some of you know, let's say DOE, they have all these national apps, they have hardware budgets, they plan for it. They also had this ECP program, if many of you are familiar, like Exascale Competitive Project, so they really came up for 5 years. But now what has happened is that money has dried up. So it is only people are operating on the pure hardware, whatever is available, until they are coming up with the next phase of funding. So as long as you sustain the funding, then the softwares and all can continue. Otherwise, now there is almost like a 1 year gap there. A lot of people actually have left. A lot of national labs and all, industry have picked them up. So I don't think those softwares will come back, or rather whatever the momentum was there, it has been discontinued. So
DK is lamenting over a 1 year gap. We've had a 50-year chasm. Let's not go there.
I think what we could confirm is the need and the desire to invest in software, right? And that should be maybe as an advice to government. If they invest a certain amount, maybe they can invest it still between December and March, maybe in a way that can be reutilized for software over a longer time scale. And maybe you would say, what would be the desired fraction of the investment? Let's say we have 1 million, or 100 million. What fraction of the 100 million would we think should go into software?
So this is interesting. What was the investment in the ECP program, software-wise? You might not know this off the top of your head. Compared to the hardware, it was a big ratio, right?
Yes.
It was 1-to-1. It was 1-to-1. Okay. Because we looked at this last year. Yeah. 1-to-1. Yeah, we've never had anything approaching 1-to-1 in the UK.
Because we can just talk about the RSC program as part of Durham. It's a great program, has its challenges and everything, but that's kind of like a step in the right direction, like porting our code for us. I'm a scientist. I want to do science as well, and then having a research software engineer support was really critical to improve the efficiency. And so that's definitely the right thing to do. More of it.
Question here, yeah.
So I think UKRI is now defining a digital research infrastructure as data and compute and software and people. And we need those four, you've just been discussing a relative balance between compute and software. Where do you think the data story is going to go within this? How do we make sure that the facilities that you've been talking about have access to the
You could say data is software and hardware. It's the same split, isn't it? It's just either software or it's hardware. So I just divide it into software and hardware. You've got software for data.
I guess possibly the fraction of 100 million that would go into storage versus HPC, like compute. I think we see as the HPC capacity goes up, where is the storage capacity following? Right? We see this. Every year I buy a new server to store more data, but obviously that's just what I do for my own data. We also have some direct projects on that.
The ratio of computer data is very application dependent. It's difficult to make a generalization. I don't think one can.
It's very field dependent.
But in the data, of course, there's a storage part where you need the storage to put the data. But the usability aspect of the data, this is where the software comes in. Yeah. How effectively, how quickly you can use this, what kind of APIs you provide. Unless you invest on that part, you just have the raw data, put them into storage with some basic APIs, and it will not be that much useful.
Yeah. So you can start to think level we have the collaboration with Scott Klaski. Some of the ideas that he is throwing out from Oak Ridge in data reduction, and what parts of the data do you actually store. You can do really clever things there, but again, it takes investment in the people and the software to unlock those benefits. Otherwise, you just keep doing things the same stupid way you've always done them.
Yes,
because stupid cheap in the short term.
Yes.
Okay, there was a question here. Yeah.
My rather than a question is a comment on decay earlier point. Should not also the UK start to invest on national lab as part of our digital infrastructure? Because we have got a national lab. However, they mainly run experiment in particle physics. Do they should do a bit more, particularly related to computing?
They do. RAO and Hirschi, their national labs, they do a lot actually, especially in data. So we have those two national labs, which are probably the closest we have here to a kind of a DOE. Hirschi labs up in Daresbury and Radford Appleton. Exactly. So I would say we have the progenitors. We're just lacking. Well, that's what I say. We don't have first we need a strategy, and then we need to be able to fund that strategy. A good paper was written, wasn't it, in March 23, the Future Compute Review. It was all in there. We just need to bloody implement it.
Okay, we need to wrap up, but I think Mark had a question.
Yes,
you want to grab the mic?
So if we were putting a large fraction of the budget for the DRI into people, there's two issues with that, and you've only got 1 minute to discuss it. One issue is obviously it means the systems we get are smaller. Is that okay? Are we comfortable with that? And two, where are we going to find the people? So if we had 200 million to spend on people per year, let's say, in an imaginary scenario, where would we find those people now? Because I take your point, Raphael. We can be clever about how we spend the money, but where do we find the people?
Go ahead.
I think two systems that can be put in place. One is one where there's a clear career progression, so that people can stay in the career path. The other one is to accept the fact that the people will not stay there forever. But so we set a stage in people's lifetime or career where this is the right time for them. It can be just PhD, roughly PhD, postgrad level, and it's like perfect training, and we accept that you have a high turnover. It can be implemented as a model, I think. I would prefer a longer term career, but the two systems can be implemented if we know from the start that this is the model that's going to work.
Yeah, we capture a lot of those PhD students that we lose. I mean, one thing we have done well is all the postdoctorate training centres that have sprung up all around the country in disciplines which are very supportive of that kind of mission. We're growing them at that level really well, actually, but then there's no, that funnel after that, they will filter away out into, well, it's still valuable for the country, they filter out either into science or into industry. We need to catch some of those ones we're growing at that really early stage. I think if we had exciting programs, we would be able to catch more of them. And the feeder at the bottom is there, we're just missing that middle layer, possibly. But it would take time. We couldn't just suddenly turn on that switch, could we? It would take years to scale up. So that's why it needs to be part of a 10-year strategy.
Okay, right. Well, let's thank the panel.